Welcome to the masterclass, everyone. Okay, let's dive right into this insider's guide. Today, we are unpacking a concept that is quite literally the beating heart of the Cambridge Mathematics exam series. Whether you are building your foundations in syllabus codes 0580, 0606, 4024, 4037, 4040, maybe pushing up into 9231, or directly tackling the 9709 AS and A level, this explainer is absolutely crucial for you. We are talking about mastering the integration of the form ax plus b all to the power of n. Now, I like to call the approach we'll use today the symphony conductor strategy. Why? Because passing Cambridge Mathematics isn't just about throwing a bunch of numbers at a page and hoping something sticks. It's about orchestrating your arguments so perfectly that every single line of working acts like an instrument in harmony. Picture a real Cambridge Mathematics past paper question right now. It's a classic high-stakes integration problem. I want you to imagine a dynamic split screen with a tension-building timer ticking down. On the left side of our screen, we have a student named Alex. Look at all that red ink on Alex's paper. Alex panics and overloads the page with raw mathematical facts and random formulas, jumping straight to conclusions without any structured analysis whatsoever. On the right side, we have Sam. Sam rushes the entire process, racing against the clock, and completely misses the specific command word requirements in the question prompt. Both of these approaches, they are guaranteed mark losers. Today, we're going to completely transform how you approach these papers. We're going to show you exactly how to avoid being an Alex or a Sam, and how to start thinking and writing exactly like a principal examiner. Here is our roadmap for today's explainer. We'll hit our theoretical foundations, dive into the method mark strategy, and finish up with critical examiner warnings. Let's get right to it. Section 1. Theoretical foundations. What are the examiners actually testing? Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's build from the ground up. Our starting point is incredibly simple, but it is the absolute core of everything. Integration is the exact reverse of differentiation. It sounds so obvious, right? But the principal examiner reports tell us that students routinely forget this fundamental truth when they are staring down the expression ax plus b to the power of n. Think about when you differentiate this expression using the chain rule. What do? You multiply by the power, you decrease that power by 1, and this is the absolutely crucial part. You multiply by the derivative of the inside of the bracket, which is a. Therefore, logic dictates that the exact reverse process, integration, has to undo all of those steps in the exact reverse order. So, what's the move? You increase the power by 1, you divide by that new power, and here is the ultimate step that everyone, including our friends Alex and Sam, always seems to miss. You must divide by the derivative of the inside bracket, a. So the fully integrated form becomes ax plus b to the power of n plus 1, all divided by a times n plus 1. Understanding this fundamentally as a reverse process, rather than just some standalone rule you crammed into your brain the night before the exam, is exactly what separates the top-tier candidates from the rest of the pack. It's about seeing the machinery underneath the math. You see, the examiners are designing these questions to test 3 specific mental muscles: knowledge and understanding, application, and analysis. They want to see the whole package. To hit all 3 of these domains perfectly, top students actually structure their math answers using a framework adapted from essay subjects. We call it the PEAL framework: point, evidence, explanation, link. In mathematics, this translates beautifully, and it's a real game changer. Point, you state the correct integration rule. Evidence, you show the explicit substitution of your specific values into that rule. Explanation, you perform the algebraic manipulation clearly, step by step. Link, you deliver a final answer that perfectly addresses the specific command word and context of the question. Imagine a 30-second timer on the screen right now. If you were to look at 2 answers, one that's just a jumble of numbers and one that follows point, evidence, explanation, link, you'd spot the winner instantly. When you master this PEAL framework, you are proving to the examiner that you don't just have basic knowledge, but you have the deep analysis required to structure a flawless mathematical argument. The crucial takeaway to remember here is that Cambridge prioritizes analytical depth over superficial breadth. This brings us right back to our students from the beginning, Alex and Sam. Alex tried to show superficial breadth. Alex was writing down every integration formula under the sun, hoping the examiner would just pick the right one out of the muss. Spoiler alert, the examiner won't. Sam, on the other hand, lacked analytical depth entirely by rushing to a final number without showing the orchestral harmony of the working out. Academic benchmarks at this level require logical, structured reasoning. Deep, step-by-step understanding beats rote memorization every single time. Every single line of your working out is a sentence in a paragraph. If you skip a line, the paragraph stops making sense, and the symphony falls apart. Moving on to Section 2, the method mark strategy. This is all about earning points through your process. This brings us to a massive, critical alert pulled direct from the examiner's playbook. Even if your final answer is wrong, method marks can save you. I literally cannot overstate how important this is. We are moving into the transformation phase right now. Imagine all those red pen marks on Alex and Sam's papers magically transforming into green check marks. How? Through the mathematics success blueprint. Students lose massive amounts of marks simply by not showing they're working. Let's say you are integrating 3 times the bracket 2x plus 4 all to the power of 5. If you apply the integration rule perfectly, but you make a tiny, silly arithmetic error in your final division on your calculator, you might get the final answer mark wrong. But if the examiner sees that you explicitly wrote out the step of dividing by 2, which is the derivative of the inside bracket, you will secure the method mark. You earn points for the process. Show the harmony. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, welcome to our interactive workshop. We are going to put this into practice. Think of this as Challenge 1, Data Scan. Imagine a complex math chart or data table on the screen and a 60-second visual countdown timer ticking away. When you see a complex integration question, you must run this precise deconstruct, solve, evaluate loop. Step 1, identify given information. Is it a definite or indefinite integral? If it's indefinite, do you have a coordinate to find the constant c? Extract that chord trend immediately. Step 2, break into logical steps. Identify your a, your b, and your n in the expression ax plus b to the power of n. Step 3, solve systematically using that exact Peel framework we just discussed. Step 4, check for reasonableness. If you differentiate your answer, do you get the original question back? Step 5, make justified recommendations, or, in the context of pure math, ensure your final formatted answer directly addresses the specific command word of the prompt. Let's move right into Challenge 2, find the flaw. I want you to look closely at these 2 approaches. On the left, we have the final answer only approach. This is our flawed sample paragraph. The student just wrote the integral sign and then skipped straight to a simplified fraction. Can you spot the sentence losing marks? The examiner's commentary here is absolutely brutal. 0 method marks awarded because the cognitive process is completely hidden from view. Now contrast that with the systematic analysis on the right. This is 100% Cambridge approved. There is clear annotation. The student has explicitly written using integration of ax plus b to the power of n rule. They have shown the unsimplified fraction first, actually showing the power increasing and explicitly showing the division by the inner derivative before they even attempt to simplify. This presentation follows strict conventions. It uses proper formatting and leaves absolutely 0 ambiguity for the examiner. And that brings us to Challenge 3, speed writing. Imagine a 30-second timer counting down right now. If you had just 30 seconds to write one perfect analytical Peel paragraph for a math step, what must it include? You must apply correct formats. Do not forget your dx at the end of the integral. Do not forget your plus c for indefinite integrals. You must use appropriate terminology. And crucially, in your structured reasoning, identify your limitations and assumptions. For instance, you need to know that the rule for integrating ax plus b to the power of n only works when n does not equal -1. If n is -1, it becomes a natural logarithm function, which is a completely different ballgame. Evaluating the evidence quality in math means recognizing the precise limitations of the formulas you are applying. Let's transition to our final phase, Section 3, Critical Examiner Warnings. As we build our final answering system today, you need to know that there are 3 specific, highly recurring errors that students make year after year after year when integrating this specific function. Let's reveal them so you never fall into these traps. Here are the top 3 mistakes, and avoiding them is part of the 3 rules that guarantee top marks. Trap number 1, confusing cause and effect. In the context of integration, examiners constantly report that candidates confuse the rules of differentiation with integration. Instead of dividing by the derivative of the inner function a, they multiply by it. They let the stress of the exam room blur the lines between the original function and the integrated function. Trap number 2, forgetting to check format and presentation. This is dropping that constant of integration plus c, or forgetting to evaluate your limits properly in definite integrals. It's sloppy presentation that costs you those precious method marks we just spent so much time talking about. This ties directly into our rule of Peel framework application. Your presentation matters. And trap number 3, answers are not specific to the context given. If the command word asks for the exact area under a curve, and you leave your answer as a rounded decimal instead of a precise fraction or a surd, it means you haven't paid attention to the context. This violates our rule of command word decoding. You must always evaluate your performance against the specific command words of the question. To lock all of this in before exam day and to help with your time management matrix, here is a powerful memory hack. Create a mnemonic using the first letters of the key procedural terms. I like to use IDD. Increase power. Divide by new power. Divide by inner derivative. IDD. Say it to yourself every single time you see a bracket with a power in an integration question. Increase, divide, divide. It's a simple, targeted way to ensure you never ever miss that crucial final step of dividing by the inner derivative. It will save you time, and it will save your grade. Finally, I want to leave you with this provocative thought. How will you shift your focus from simply finding the answer to mastering the deconstruct, solve, and evaluate process? The next time you sit down with a past paper, are you going to be an Alex, throwing random facts at the page? Or are you going to be a Sam, rushing the command words? Or are you going to be the symphony conductor, orchestrating every single mark with precision and analytical depth? Listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep practicing, trust the process, and I'll see you in the next one.